There's a second way to find the inverse of a matrix, and this method uses the fact we're kind of cross-multiplying the matrices. Take into consideration capital D is A times D minus B times C. Then the inverse of matrix A is going to be 1 divided by D times the matrix D, negative B, and negative CA. And of course, this does not take into consideration D being 0, because if you get 0 in the denominator, we know that this gives you an undefined answer. So AD minus BC cannot equal 0. If this is the case, then the matrix A does not have an inverse. So I want to look at two examples to demonstrate how we would find this matrix for matrix A. First of all, we need to find D. If D is A minus D, A times D minus B times C, and A is 1, B is 2, C is 3, and D is 4, we plug those numbers in, and we have 4 minus 6, which is negative 2. And so now we just plug this into the inverse formula. 1 over negative 2 times, and now we have to plug our numbers back in. D is 4, negative B is negative 2, negative C is negative 3, and A is 1. And notice we switched the places of 1 and 4, and then we just made the B and C term negative in order to get our inverse. But for our final answer, for our final inverse, go ahead and multiply your negative 1/2 times everything inside your matrix. So negative 1/2 times 4 is negative 2. Negative 1/2 times negative 2 is a positive 1. Negative 1/2 times negative 3 is a positive 3/2. And negative 1/2 times 1 is negative 1/2. So negative 2, 1, 3/2, and negative 1 is your inverse of the matrix 1, 2, 3, and 4. Now let's look at the second example with the matrix B, 3, 2, 6, and 4. First of all, we are finding D. We're calculating the AD minus BC. So that is 3 times 4 minus 2 times 6. And notice in this example we see that D will become 0. 12 minus 12 is 0. Anytime D is 0, this means that B does not have an inverse. In other words, B inverse does not exist. And we would say this is our final answer.